Let us talk about how to measure technical progress with the use of production function. So let me just start drawing an isoquant here, right? This is an isoquant which is producing Q naught amount of output, right? And so there are different combinations of K and L which are used to produce Q naught amount of output, right? And with technological progress, what has happened is that the same level of output, right? Same level of output, it could be produced with a fewer level of input. So I'm calling it as Q naught dash. Means Q naught dash is also producing the same level of output as Q naught, but with a lesser amount of inputs, right? So please write with technical progress, right? Same level of output can be produced, right? With fewer inputs. With fewer inputs, right? For example, what Nicholson says, he says like this. He says that let's say you are at this point. Let us say you are at this point, hmm, and you were using, let's say, K1 amount of capital and L1 amount of labor to produce this level of output, right? Okay. Now, if you want to produce the same level of output after the technical progress, right? After the technical progress, with the same amount of capital, I mean, you might require lesser amount of labor also. Guys, there is no difference between Q naught and Q naught dash. The only thing is that this Q naught dash is the same output level as Q naught, but it is using lesser input. So if you want to produce the same level of output, right, you can produce that. But the only thing is that, you're using lesser amount of labor now. That is true, right? That is true. So with the K1 amount of labor, with K1 amount of labor, sorry, with K1 amount of capital, it takes only L2 amount of labor, right? It takes only L2 amount of labor to produce Q naught, right? Okay. Acha, you tell me one thing. One more thing I just want to write. This, uh, or I mean, I hope you understood this, that this isoquant has shifted inwards, although it is producing the same level of output, but it is using fewer inputs, right? Okay. Now, what has happened is, what has happened is that per worker, output per worker has increased from Q naught upon L1 to Q naught upon L2. That is true. So every unit of labor is now producing more level of output with technological progress. So here beta numerator is same, but denominator L2 is lesser. So Q naught upon L2 is more. So the productivity of labor is more, right? That is there. But you need to be careful. But one must be careful, right? If you would have used a little higher amount of capital here with a lesser amount of labor, right? If you would have used a little higher amount of capital with a lesser amount of labor, then also output would have remained same. uh, then also output would have remained same. But that is not technological progress. Technological progress is with the same level of inputs, you are producing more, or the same level of output could be produced with a lesser amount of inputs, right? But one must be careful, right? An increase in capital, an increase in capital would have allowed a decrease in labor input. Okay, or you can write an increase in capital to K2 would have allowed a decrease in labor input to L2, hmm, right, along an original isoquant Q naught. Along an original isoquant Q naught, right? So output per worker has increased, right? But this is not a technological progress, right? Technological progress would be given the amount of inputs, you should be able to produce more, or given the amount of output, you should be able to reduce the amount of the input usage, right? in this case, in this case, output per worker has increased. That's there now. Output per worker has increased. But there is no technological progress when you're using more capital. Output per worker increased. Although, although they would have been, although there would have been no technological progress, right? So when you use the production function concept, I mean, then you can distinguish between whether this growth in output has occurred because of technological progress, or it has occurred because of the the changes in the usage of inputs, right? So there you can distinguish, right? So you have, let us say, mm, your Q is the function of so do you understand this? Your output can increase because of the technological progress, Or it can also increase, given the technological progress, it can also increase because of the changes or the higher usage of input. So you use more labor and more capital, you'll be able to produce more, right? Or with the same amount of labor inputs and the capital input, with the higher technological progress, you'll be able to produce more, right? So over time, historically, what economists have found out that when output is growing, that growth in output is more than the growth in input. So there is something else which is also driving the growth in output. You understand that? And that something is nothing but the technological progress. So what they found was that the growth in output is more than the growth in inputs, right? So there is something more which is also adding to the growth in inputs, which is creating the growth in output, right? So historically, the rate of growth of output over time has exceeded the growth rate that can be attributed to the growth in conventionally defined input, right? So let us just try to find this out. It's easy and you'll really like that. Yeah. So you have what? dq by dt. Okay, let me just write the equation first. So q is equal to 80. So this is changes in a represent the technological progress. Okay, let me just write that as well. So if q is equal to 80 f of kl, changes in a represent technological progress. So let us just try to find out how output is growing over time. So you just use the product rule out here. So what you have is dA by dt, first function as it is into derivative of second, right? Plus second function as it is into derivative of first, which is df of kl by dt, df of kl by dt. So let us just write that. Acha, you tell me one thing, guys. We have q is equal to a into f of kl, na? So if I want to write f of kl, I can write as q by a. Hmm? Here also, q is equal to f of kl. Sorry, q is equal to a into f of kl. So if I want to write the value for a, I can write q upon f of kl. Mhm. That I can do. And that's what I have done in the next step. So you have dA by dt, right? dA by dt into f of kl. F of kl I have written as q by a. Means I have written means Nicholson has written. A you can write as q upon f of kl. Hmm. And now the derivative of f of kl with respect to t, with respect to t. Guys, I hope you know this. I mean, you differentiate this guy, f of xy. How do you do that? Del f by del x into dx plus del f by del y into dy. That's what you do. And when you do it for time, so it will be del f by del x into dx by dt, del f by del y into dy by dt. This is the way you do it, right? A simple total derivatives, partial derivatives rule. So how do you do this? It will be what? Del f by del k into dk by dt plus del f by del l into dl by dt. Del f by del l into dl by dt. Right, beta? All of this is what? Dq by dt. Now I can do what? I can divide throughout by q. Dividing throughout by q. So you get what? Dq by dt upon q is equal to what? dA by dt upon a beta. This q upon q will get cancelled out, right? This q upon q will get cancelled out. Okay. Now what you have? Again, when you divide this thing by q, this thing is also gone. So I'll take one more step in order to write that. Huh? You have like this. So how do you write? dA by dt upon a plus. How can I write this? I can write this del f by del k in the numerator upon this f kl into dk by dt, right? Again, I can write this del f by del l in the numerator upon f of kl dl by dt. This is what? dq by dt upon q. This is what, beta? dq by dt is what? Q dot upon q. Acha, one more thing is, when you write x dot, that is dx by dt. That would mean instantaneous change in x. And when you write x dot by x, that is the proportional change in x or growth rate in x. That is the proportional change in x or growth rate in x, right? So it is q dot by q. dA by dt is what? A dot by a plus Okay. Now, can I write this as this? Del F by del K. Okay. uh, Del F by del K into, can I just divide and multiply by K, right? This guy. So I have here multiplied and here I have divided. So I've just multiplied and divided by K. So there is no difference. It doesn't make any problem at all. Del F by del L upon, okay, write it like this. Del F by del L into, you just divide and multiply by L. Mm-hmm. You just divide and multiply by L. You with me? Okay. Now this Q dot by Q beta, that is nothing but the growth rate in Q. A dot by A is nothing but the growth rate in A. Plus this guy, this del F by del K into K by F, that is nothing but the elasticity of output with respect to capital, right? This is the elasticity of output with respect to capital. Okay, I'll just come to this point. This is what? dk by dt, growth rate in capital, plus this thing, del F by del L into L by F. This is the elasticity of output with respect to labor, into, what is dl by dt? This is gl. This is your dl by dt by L. This is the growth rate in labor. Beta, what is this? EQK, that is del Q by Q whole upon del K by K. That is the proportionate change in output upon proportionate change in capital. Del Q by del K into K by Q. This is the elasticity of output with respect to capital. Similarly, you have EQL, that is del Q by del L into L by Q. This is elasticity of output with respect to labor. And this is what my growth accounting equation is. This guy, right? This guy is what my growth accounting equation is. Hmm? So if I have the values for how capital is growing, how this guy is growing, elasticity of capital and labor, I have the growth rate of output also. I can find out how much of that growth rate could be attributed to the growth rate in technology, that is GA, right? This is also the growth accounting equation which we have. Amita? Okay, so this is what I wanted to do in this class. Thank you.